Right. So till now I have seen solving a linear equation numerically. So we have seen solving a single equation numerically, and if you are given multiple equations, like we have studied only about solving for a single variable. So if there are multiple variables and multiple equations, so in that case we'll be using matrix methods. Okay, so let's say we're given three equations with three variables. So the number of equations required is equal to, should be greater than or equal to number of variables. Let's say I'm considering three variables. Let's say x is 1, y is 2 and z is 3, and I'm developing three equations using those variables. So all the three must be independent. So I'm considering x plus y plus z is equal to what? It is 6. 2x plus 3y plus 4z . 2 plus 6, 8, 12, 20. X plus y minus z is 0. Otherwise, take any other variable. 3x plus y minus z is 0. 2. Okay. So the simplest method is Gauss elimination method.
Hey, बोलते को एक वीक पनी आएगा
Right. So simplest method is Gauss elimination method. So here we write all the equations in the form of a matrix with all the quotients and the result. Like it is 1 1 1 6, 2 3 4 20, 3 1 minus 1 2. So the only condition is the diagonal element should not be 0. So in some equations we may have equations with two variables sometimes. So in that case we have to rearrange the equations in such a way that the diagonal element should not be 0. That is the starting condition, initial condition. So then we make all the diagonal elements are called pivot elements. So below that every element should be converted to 0 using row operations, only row operations. So that too we should not touch the existing element. So let's say I am applying row operations on this. So I am considering one by one element as a pivot first of all, and the row operation for this is R2 should be modified as, I should not touch R2. Whatever may be the modification I have to apply on R1. So it is 2R1. And for R3, R3 minus 3R. Even if there are fractions, or you may get sometimes fractions also, even then you should not touch the existing row. All modifications should be applied on the pivot element only. Okay, so what do you get? So this remains same. So you have to multiply this row twice and subtract. This becomes 0, 1, 2. And this is 8. I have to multiply row 1 with 2 and subtract from row 2. So other one also I have to multiply this one with 3 and subtract from here. So this is 0, minus 2, minus 4, 2 minus 18, minus 16. Same way, now I have to consider this as a pivot and I have to make other elements 0 below it. So here the row operation is R3 plus 2R. So I will to multiply second row twice and add to third row. This is 1 1 1 6, 0 1 2 8, 0 0, what? So this set of equations are becoming dependent. So these are linearly dependent, so cannot get a solution from this. So I have to take another set of equations. Let's modify it. Make it plus 2 then. What do you get? 3 plus 2, 5 plus 3, 8. This is plus 1. So when you apply row operation, 1 minus 3 is minus 2. Eight minus 18, minus 10. So what do you get here? So you have to multiply with 2 and add. So this is 2. Eight to 16, minus 10, 6. Then you have to go for back calculation. From this equation, you have to get all the values. So here this equation is what? 2z is 6. That implies z is 3. Substitute this value in the previous one. So it is y plus 2z is 8. Z is already 3. So y plus 2 into 3 is 8. Y is 2. Substitute these two values in the previous one. So x plus y plus z is 6. So x plus 2 plus 3 is 6, or x is equal to 1. So once you make the lower triangle 0, you have to fetch the values from bottom. So So next one, improvisation to this one is Gauss-Jordan method. So here instead of this lower triangle matrix, we'll completely develop a unit matrix. So every time we'll be modifying the elements below and above the pivot element, and finally we make all the diagonal elements unit. So once this level is completed, okay, we'll be taking the same set of equations. So 1 1 1 6, 2 3 4 20, 3 1 1 8. So first set is okay, the same set of operations. R2 is R2 minus 2R1. R3 is R3 minus 3R1. So you'll get 1 1 1 6, 0, 1 2 8, 0 minus 2, minus 2 and minus 10. Up to this level it is same. When you are considering the second, you have to make the elements below and above the pivot element 0. So what are the row operations now? So if the pivot is 1, you have to make this 0. So the row operation is R1 now becomes R1 minus R2, and R3 is R3 plus 2R. These are the two row operations. So you have to subtract second row from first. So this is 1, 0, 1 minus 2. You have to keep R1 first. 1 minus 2 is minus 1. 6 minus 8 is minus 2. Next one, this is same, 0, 1 to 8. Next one, you have to multiply the second row twice and add. This is 0. 4 minus 2 is 2. This is 16 minus 10. 6. Next level, you have to consider this element as pivot, 3 element as pivot, and make all the above elements zeros. So what are the row operations? R2 is R2 minus R3. So every time whatever row you are operating on, it should be untouched. You should not modify it. Whatever modifications you are making should be done on the pivot element only, pivot row. Okay, so you have to subtract R3, and for row 1, R1 plus R3 by 2. You have to divide third row and add. So what you get? So this is 0 0 2 6 as it is, 0 1 0. Just have to subtract row 3. So this is 2. Next one, 1 0 0, So you have to divide the third row by 2 and add. So 3 minus 2. This one. And final stage is you have to make all the diagonal elements 1. 2 are already set and remaining. So whatever row operations here it is same. R1 is R1. No change. If at all any modifications are required, you have to do it here. Then it is 1001, 0102, 001. This is the end result. X is 1, Y is 2, Z is 3. So coming to FORTRAN programming part, you have to learn how to read and write two-dimensional matrices in FORTRAN. Okay. So the default order of reading and writing of matrices is in columns. So usually we read and write matrices in rows, right? A11, A12, A13 in rows. But default sequence of reading and writing in FORTRAN is in columns. So that we'll check and confirm now. And there are some additional features for FORTRAN arrays. So that will add some flexibility for us. And that also we'll see. So I'm defining the matrix here. So I'm asking user to enter 9 elements. It's okay. So I'm asking user to enter 9 elements. And this read operation can be done in 3 different ways. Okay, so everything can be done in a single row by using implied do loop. So here the entire do loop can be written in a single line. Okay. So read. So simple option is read A. It reads all the elements, all 9 elements, and prints all the 9 elements in a row. But here we don't know how it stores the data. Okay, so because it is reading the data and it is storing it in some sequence which we don't know actually. So to know that, do one thing here. I'm giving index to the rows and columns. So the first index is for rows and second index is for columns. Okay, so I want to print the first row first and second row and then third row in a sequence. So the variables are A11, A12, A13. So the column index should be changed first and then the row index. So I have to change. J is 1, 2, 3. And then I have to change I value. So this is called implied do loop, and this operates from left to right. So first the loop enters with I value. I value takes 1. Then J value takes 1. A11 will be printed. Then this operation is completed. It goes out. J value varies. J becomes 2. So A12 will be printed. Next A13. And then the control goes outside again. I becomes 2. So 2, 1, 2, 2, 2, 3. Then 3, 1, 3, 2, 3. So here you will see how that the data is stored. So here also the entire operation is completed in a single line. So all the data will be printed in a single line. And alternative method to this is write the do loop in a proper format. Like so this is one way. So here one row will be printed in a single line. Let's say with 1, I value 1, the control enters into the loop. So A11, A12, A13 will be printed in a single line. Next the control goes to next line because this statement is completed. So for 2, I value 2, the result will be printed in the next line. A21, 22, 23 will be printed in the next line. 31, 32, 33, next row will be printed in next line. So here everything will be printed in a single line because the entire statement is in a single line. So here for each row, the control goes to next line. And if you want to print every element in each line, element wise, the result will be printed as a column if you write it like this. So here the loop index 10 is already used. So 11. Closes here and 11. So the default way of reading a matrix is in terms of columns that you will see here once you print that. So once you realize that it is convenient to read the matrix in row wise. So default is column wise, it stores the data in A11 first, then A21, A31. It's like that. But for our convenience, we will be using this. reading in terms of rows. So once you realize that, you can apply this type of syntax for reading also and verify that.